Earthquakes are a stark reminder of the immense power that lies beneath our feet. They are a force of nature capable of unleashing unimaginable energy in an instant. While we marvel at the beauty of our planet, we must also respect its awesome and sometimes destructive potential. When it comes to earthquakes, the ground beneath us becomes a stage for a dangerous dance of tectonic plates. The consequences can be devastating, particularly for those living in earthquake-prone areas. Buildings, the very structures meant to protect us, can transform into deadly traps if not designed to withstand seismic forces. The urgency to construct earthquake-proof buildings is not a matter of if, but when. The aftermath of an earthquake paints a grim picture. Collapsed buildings, rubble-strewn streets, and the heart-wrenching loss of life are all too common. The sheer scale of destruction is a stark reminder of our vulnerability to nature's power. But amidst the tragedy, a crucial lesson emerges. The difference between life and death often lies in the quality of the buildings we inhabit. Earthquake-resistant structures stand as beacons of hope, symbols of human resilience in the face of natural disasters. They represent a conscious choice to prioritize safety and protect our communities from the unpredictable nature of our planet. The time to act is now. The urgency for earthquake-proof buildings is escalating at an alarming rate. This is driven by a confluence of factors, with urbanization taking center stage. Cities are expanding rapidly, often encroaching upon areas known to be seismically active. The allure of city life often overshadows the inherent risks posed by earthquakes. As populations swell in these vulnerable regions, the potential for catastrophic loss of life and infrastructure grows exponentially. We are building a future where megacities are often located on a seismic tightrope. Climate change further complicates this precarious scenario. It's not just about the earthquakes themselves, but also the secondary disasters that often follow. Climate change is increasing the frequency and intensity of extreme weather events. Earthquakes can trigger landslides in areas experiencing heavier rainfall due to climate change. Coastal cities, already threatened by rising sea levels, become even more vulnerable to tsunamis triggered by undersea earthquakes. The interconnectedness of these threats demands a holistic approach to urban planning and disaster preparedness. The history of earthquakes is unfortunately replete with tragic examples of what happens when we fail to prioritize earthquake-resistant construction. The 2010 Haiti earthquake, a devastating 7.0 magnitude quake, is a poignant case in point. The earthquake's epicenter near the densely populated capital of Port-au-Prince resulted in widespread destruction. Buildings crumbled, infrastructure collapsed, and hundreds of thousands perished. The tragedy was exacerbated by the fact that many structures were not built to withstand seismic activity. Similarly, the 2001 Gujarat earthquake in India serves as another stark reminder. The 7.7 magnitude quake devastated the region, claiming over 20,000 lives. Thousands of buildings collapsed, turning homes, schools, and hospitals into tombs. While these tragedies are heartbreaking, they offer invaluable lessons. They underscore the urgent need to prioritize earthquake-resistant building practices. The cost of inaction far outweighs the investment in safer structures. Designing structures to withstand the unpredictable fury of an earthquake is a formidable challenge. Earthquakes generate immense forces that act upon buildings in all directions, vertically, horizontally, and even torsionally. Engineers must account for these multidirectional forces, ensuring that buildings can resist both the initial shock waves and the aftershocks that follow. This requires an intricate understanding of soil mechanics, structural dynamics, and material science. The task is made even more challenging by the unpredictable nature of earthquakes themselves. Their magnitude, epicenter, and depth can vary greatly, making it difficult to create a one-size-fits-all solution. Furthermore, the geological conditions of the building site play a crucial role. Soil types, groundwater levels, and proximity to fault lines all influence a building's vulnerability to seismic activity. Therefore, earthquake-resistant design is not a cookie-cutter approach, but rather a site-specific endeavor that requires careful analysis and adaptation.